So that was a summary of 6 common enhanced inspection technologies. Now, there are other enhanced inspection technologies out there that MnDOT uses. MnDOT uses things such as pole cameras. Um, there's some other inspection technologies such as JPEG mosaic cameras that are currently being developed in the industry. So it's an evolving uh, amount of technology. So as MnDOT moves forward, you definitely want to keep track of the state of the industry and best practices of new and innovative technologies. So moving from a summary of technologies, what I'd like to talk about now is considerations of quality control as you conduct enhanced inspections. Now for video-based inspection, so we're talking CCTV or HIVE camera inspection. The most important thing to keep in mind is that you need a good quality of video as you go about and do the inspection. Poor quality video is not going to give you the data that you need to make engineering-based decisions on what to do about a defective or damaged culvert. So to help better improve the review of CCTV inspection, what we did as part of this manual is identify 10 components of quality for a video-based inspection. So going down that list here, the first thing you want to do is make sure that the vendor that you're using has high quality video. So in the industry, it's very common to have DVD quality or better image. So if you hire somebody and they're giving you image quality that's less than DVD, so maybe you're getting VHS quality video, you want to ask them some follow-up questions because the industry standard really has moved towards DVD or better. You want to make sure that the color of the image is true to the color within the culvert. So we very much rely on identifying discolorations uh, on culvert walls to identify defects. So that, a discoloration could identify a soft spot in a CIPP liner, or it could identify the start of corrosion. So you need to make sure that the image quality is not oversaturated where you can't actually see anything. Lens condition. You want to make sure that the camera lens is clean throughout the entire inspection. So if the camera operator drives their camera through debris or through water, and now you have grease all over the lens, it's best practice to remove the camera, clean that lens, and then redo the inspection. Lighting is very important. You want to make sure that the camera unit has an appropriate amount of lighting on it. So obviously you want to make sure there's enough lighting so that you can see the entire interior surface of the culvert. But also you want to make sure it's not overlit. Right here, what we're seeing in the upper right corner of this slide is an example of an overlit culvert. So my guess is what's happening here is they had a lot of light for a much larger culvert and they put it into a smaller culvert. And so the lighting here is bleaching out the pipe wall. So you're not really able to see defects like small cracks or fractures in the pipe wall. So it's important that we have not too much light, but also not too little light. You want to make sure that the digital footage counter on a CCTV camera is accurate. So what we're seeing here in the lower right-hand corner is a guidance figure from NASCO about how you should calibrate the footage counter. So in essence, what you want to do is make sure that the footage counter is set at 0 feet as the camera enters the culvert. Doing that, having that calibrated properly allows you to understand exactly where the damage is in the culvert relative to what's going on above the culvert, so maybe at the road surface above. You want to make sure that the camera is centered down the barrel of the culvert. You want to have a centered view throughout the inspection. The upper right-hand corner here, what we're seeing is a camera that's not centered down the culvert. And so as you can see, it gives you a real cockeyed view of what's going on inside that culvert. Now, this is a corrugated metal pipe, so we're interested in understanding the ovality of the pipe. Is it starting to deform? And so understanding deformation is very difficult if the culvert isn't really centered. So, you have a skewed view here, so it's hard to say, is this pipe perfectly circular? You want to make sure that there's a controlled speed of inspection throughout the culvert. So best practice, as recommended by NASCO, is that you don't exceed a speed of 30 feet per minute as you go do your inspection. You want to make sure that the inspector is completely stopping the camera as they view and video document damage that they're seeing in the culvert. Nothing's more frustrating than a drive-by where they just drive past damage without fully stopping and taking the time to document the full scope of the damage here. You want to note any condition inside the culvert that's going to impact the quality of your inspection. So if the culvert's full of debris and it needs pre-cleaning, because otherwise you're not able to really get a full view of the culvert, sometimes it's best to not do the inspection that day, call it off and have somebody come in and clean that line before you do the inspection. You also want to look at environmental factors that might impact the quality of the inspection. So if you try to do a CCTV inspection of a culvert immediately after a rain, there might be high levels of water in that pipe, or there might be active infiltration. Sometimes that's good to be able to document that there's infiltration or high levels after rain, but sometimes that extra water is going to obscure your view of the culvert as you do the inspection. So it might make more sense to come back and do the inspection after things have dried out a bit. A very unique situation for culverts is sunlight in the culvert. Now, when you inspect storm sewers or other types of sewers that are more closed off systems, you don't have to worry about sun impacting the quality of your inspection. Now, culverts, on the other hand, as you drive through a culvert, if you are doing that inspection at the right time and the sun's coming up over the horizon, you can get sunlight coming straight down that culvert and into the lens of your camera, and you're going to cause some severe lens flare. And that's going to obscure your view of the pipe. So what contractors do to deal with this is, a lot of times, if that's an issue, they're going to take heavy tarps and they're going to lay it over the other end of the culvert, and they're going to use the onboard lighting to light the inside of the culvert, and they're going to keep that sunlight from getting out there and into the culvert. So those are a couple of quality control considerations when you're doing a video inspection. I encourage you to go and look at the Enhanced Inspection Handbook that MnDOT developed. There's many, many more helpful hints and recommendations for controlling quality of an enhanced inspection. Now what I'd like to do is just touch on some recommendations of what type of technology one should select under certain circumstances. So let's say you have some new construction. You built a new culvert, and you have to do some sort of post-construction inspection. Now, should you do just a simple end of pipe inspection, so peek into the end of the pipe with a light and view its condition, or should you do a video inspection? Now, there's advantages in always doing video inspections, because it is helpful to have video documentation of that culvert at the day it was constructed. So it's good to be able to go back to that down the line and see, was that condition pre-existing at the time of acceptance? But the absolute musts of conducting video inspection are instances where there's high risk in that construction. So high risks might be deep culverts, or culverts that are in critical areas, so culverts that maybe go underneath the interstate, or culverts that are in a wetland and require extensive dewatering. It's good to do a detailed video inspection under those circumstances, because if that inspection discovers damage that you can then have the contractor fix before you accept, that's going to save MnDOT a lot of money. Now, if you do an end of pipe inspection and you miss some sort of damage, and you don't have proof that it was something that was constructed poorly, you might have to spend a lot of money going back in and fixing that, 2-3 years after construction. So you might have to deal with a lot of excavation to deal with that damage. So our recommendation is CCTV areas that have high risk. Consider CCTVing when the culvert is smaller than 48 inches. Culverts smaller than 48 inches tend to get a little more difficult to climb into and, do a really good visual internal inspection. So, CCTV cameras are going to be a helpful tool there. Also, just a helpful recommendation, if you're doing post-construction acceptance testing, if possible, review the CCTV with the camera operator at the time of inspection. So if the camera operator misses something that's important, or that you want some additional video documentation, they're already there, so they can get in there and they can get that for you. Say you construct a new plastic culvert, and now MnDOT needs to conduct an acceptance test to make sure that plastic culvert hasn't deflected beyond the deflection limits that are specified in the design documents. So you could use a Mandrel to inspect for deflection. You could use a laser scan, or you could crawl into the pipe and you could manually measure the dimensions of that pipe to measure for deflections. So what do you use? What's the recommendation here? Well, if the culvert is less than 48 inches, we would recommend having the contractor procure a calibrated mandrel for that pipe. There's a huge advantage during construction to be able to have a contractor do a mandrel inspection and immediately know if that pipe passes or fails. Because if that pipe fails, there's advantages in allowing them to fix it immediately, as opposed to them continuing with the inspection and having to maybe tear up some concrete or some road surface to fix a problem. Now, if the pipe is larger than 48 inches, we'd recommend person entry and manually measuring in a bunch of locations to measure for deflection. Now, laser scan does have its place for plastic pipe deflection measurements. We'd recommend using laser scan when there's a high risk for deflection. So maybe the pipe is constructed in an area that's going to receive high loads, or there's been high loads on top of it during construction, and you suspect that there might be some issues. It's good to have the laser scan in there so that you can quantify those issues. Now, if you are to have somebody laser scan a plastic pipe during construction, we recommend that you consider having the contractor procure the scanning. So put that into the specifications. As we experienced in this pilot test here, we had a several week lag between taking the laser scan inspection and getting the results. So hiring somebody to do laser scan inspection isn't exactly a fast process. So, at the speed that construction happens, it's probably best to require the contractor to be responsible for scheduling and coordinating the inspection and the results that they receive. Now, how about height infrared inspections? So these are the condition inspections that MnDOT regularly conducts. Do you use a video-based inspection like CCTV or HIVE camera, or do you do an end of pipe inspection? Well, we recommend that you always pre-screen with an end of pipe inspection. So before you go to the expense of mobilizing camera equipment to a site, somebody should go to the site and with a flashlight look in and try to see, what they can see. So they might be able to look in there and realize that, there needs to be cleaning before the CCTV camera comes out, or they might realize that site access is very difficult. So there's an advantage of having somebody do a little field recon before you get the equipment out there. Now, if you do an end of pipe inspection and the damage in that pipe can't be fully understood with eyes alone, then we recommend that you go and you schedule a follow-up CCTV or HIVE inspection. At that point, then you visually looked at it and you can say, okay, it's cost effective to have somebody come in here and do a more advanced inspection to get the information that I'm missing. All right, so those are just some brief examples of when and how you might want to apply some of these enhanced inspection technologies. Again, I'd recommend that you take a look at the Enhanced Inspection Handbook. We've got a lot more tools and helpful guidance on how to correctly select and apply some of these enhanced inspection technologies. Now, for the remaining couple of minutes here, what I'd like to do is just show you, talk a little bit more about that handbook, give you some additional resources. MnDOT developed an enhanced culvert inspection best practices manual, and this manual was published June 2017. So MnDOT wanted to pull together information about all the different common culvert inspection technologies, bring it all together in one handbook, and then provide folks with guidance as you go and use these technologies in the field. So this guidance document includes very detailed descriptions of common enhanced inspection technologies. Much more detailed than we had time to go into today at this presentation. It's got some best practices for implementing the inspections and then also taking the data and making sure that it's quality controlled. It also discusses considerations when selecting enhanced technologies for different circumstances or implementing inspection technologies. And finally, in the appendices, there are a couple of guide supplementary condition specifications, one for CCTV inspection and one for multiple sensor or laser ring scanning. Enhanced inspection technologies are valuable tools for an organization as you implement a statewide culvert inspection program. So to learn more, I encourage you to search out the Enhanced Culvert Inspection Best Practices Guidebook, which was published in June 2017. So there's a few ways you can find this. You can search Enhanced Culvert Inspection Best Practices Guidebook in a web browser, and it'll be one of the top search choices here. You can go to the Transportation Research Board website, and you can go to this link here that I'm listing. You can also go to the MnDOT research page and the web link I'm showing here as well. The other thing we're going to do is we're going to include live links to this manual in the comments section of this YouTube video. So again, it's a very helpful technology, and to learn a lot more than we had time to discuss today, I encourage you to search out this handbook and give it a look. Well, thank you all for your time. Goodbye.